So this is actually the session I was going to do at the end, but I want to move it up because I think it might be kind of fun to kind of see some of the stuff I've been talking about. This is actually called thinking asynchronously. I think I messed up on the slide here, but so let's jump in here. Today we're going to talk about asynchronous versus synchronous when you're building applications. Okay, so how does it apply to the customer? And hopefully it'll kind of help you guys understand, especially some of you guys that are building serverless applications already, how does a serverless application look in what can it do? We'll jump into this a little bit. So, you've seen this slide already. I showed it to you earlier. These are common patterns. But the specific one we're going to deal with here is the web apps and how this looks. Okay? So this is a little more specific example of a web application. This is a full-on serverless web application that you can build. I'm supposed to stay in the camera. I think I came out. I've left it quite a few times. So. All right. So here's the idea. Here's the services I'm using, and here's why. Okay. First thing I'm using is Amazon CloudFront, and I'm saving my data in a bucket. Now I can host directly out of a bucket without CloudFront, by the way. Okay. All CloudFront does is distribute my content out as it's a CDN, it's a content delivery network. Okay. So it puts it all over the world, so it's closer to the user, right? Because when we deal with latency, one of the biggest things we deal with is getting our code closer to the user, right? So that's what the CDN does. But the code is going to be stored in a host bucket on S3. Okay. The second service I'm using is this one on the bottom called Amazon Cognito. Anybody use Cognito? You guys messing with that at all? Okay. Amazon Cognito does a couple things. First thing it does is it lets you create a user pool. You can create it's a username, password, there you go, and then you can use that to handle authentication and then authorization. And the cool thing about it is built right into API Gateway is what we call a Cognito authorizer. Okay, so if you authorize through Cognito and apply apply permissions, Amazon Gateway will validate that, and then in you go. So when you're hitting Amazon Gateway, it's going to check for the token coming from Cognito and give you access to the system based on what that token, on what your scope is. The other thing Amazon Cognito does is it handles federated IDs. So if you want to tie into like a Facebook or a Google Plus or something else, a custom one, you can do that. So it ties those together. So it's very handy. Not gonna lie, it's pretty complex. Trying to work with it. Did you guys find it complex, or was it pretty straightforward? Yeah. I've been working there for a long time. There's sometimes like what? So it's complex. Authentication can be complex. Doing it right, it could be tough because you really want to make sure it's locked down. And then, as you've seen already, how we showed today, backend is Lambda, and the Lambda does my compute. That's where I do all my business logic, and then my database is DynamoDB. This is a pretty standard web application. So if you're building your front end, you could build your back end on this. And again, you could do Python, Node, .NET Core, Java, all kinds of things. So there you go. Any questions on this? Does this make sense? All right. So one of the common patterns we see, I just dropped those others so they're not in the way. This is the big Lambda approach. Okay? So the big Lambda approach says one Lambda is going to handle all my application. Now this works, and it's okay for small applications, but it can get pretty bloated as our business logic gets complex. Okay? So when I'm building that payment processing that I had or something like that, this gets pretty hairy because I've got 5, 10, 20, 100 billion lines of code. And sometimes it can be hard to maintain. So, the other approach we see, this goes back to what we were talking about earlier, is the mini Lambda functions approach. I don't know if that's a general name we use for it, but this is an example of a microservices architecture. So the idea here is I have an Amazon API gateway, and I can split across lambdas based on resource. So I can say users hit this lambda, reports hit this lambda, however my endpoints are on my API, right? Or I can even do it by method. So I could say user posts, hit the top lambda. User gets, hit the second lambda, or something like that. I can get really granular with that, however I want to do it. I can also break down the authorization, incognito, what can be reached and what can't be reached. Yes?
You said that requesting one lambda from another lambda is a bad approach.
Yeah.
So how can I implement my application that handles user requests and then reporting to someone?
Yep, I'm going to answer that as we go through that. That's a great question. So, yeah, so because what happens is, again, this is single responsibility. You all familiar with the single responsibility model? Okay, good. It means, and as a lambda, the way we do that is if we do one thing, and we do that one thing really well. And as I update, I can always update that one thing. Okay, so that's single responsibility model. It's easier to manage, logical splits like I just explained. However, that color's kind of bad. Y'all can see that blue. It's kind of a bad color, right? But what happens when those want to talk to each other, like you brought up and then you brought up? So we can call. It is possible to call one lambda from another. Okay, it absolutely works, and in most cases it's going to work fine. But it is a coupling effect. It ties those lambdas together. Okay, which we're not going to send out the Amazon police to get you, but I do encourage you to stay away from that pattern because, and it doesn't matter if you're doing serverless on AWS or you're building it within your own architecture at home or things like that. The more you decouple your microservices, the more resilient your website is. Okay, because you want to build so that if my last two lambda functions die, the rest of them continue to run just fine. Excuse me 1 second. But in general, we try to build these, we say, it's bad. Try not to do that. Okay? So, let's kind of show you an example of this. Okay, this is an example. This is a translation demo that I wrote, that I built using all the AWS translation services. And here's how it works. Okay? Sorry, I'm going to turn off. Can y'all see that? It's just a little bit of data. All we're sending is, it's just a JSON object. And it's data, and it just says, hello, welcome to my translation demo, and it sends a culture. Because with browsers, we deal with cultures. And so your culture is usually two sets of digits. Like for Russian, I think it's RU dash upper RU. So it tells you, hey, it's a Russian language in Russian. In English, we have English Great Britain, English America, English, all of it. So all kinds of. So that's what it sends. Okay? And so here's what it's going to do. This is the big lambda function. So my user authenticates their Amazon Cognito, and the website you see is stored in a bucket. Okay, and I actually don't have authentication on this side. I'm going to show you. So if you want to go out and play with it, you're welcome to. Each culture is sent to Amazon. So it comes in, and then this lambda function breaks out each culture and sends the translation and that culture to Amazon Translate. So if I have 4 cultures, then there's 4 requests to Amazon Translate, right? And then it sits there and it waits. So that Amazon that lambda is active, okay? And it's waiting. It's a synchronous call. When it gets that data back, it then writes. It holds that data. We're almost kind of doing state. The next thing it does is it takes each of those returned translations and it sends it to the service called Amazon Poly. Amazon Poly then turns those translations into an audio file and streams it back to, or a buffer back to the Lambda. Okay? The Lambda then takes that return data and drops those as files into an audio bucket. Okay? And then it gets a response back from there where those are sitting, and it takes all the data and stores it in DynamoDB. Okay? So you see the steps that are going on here. Now, what happens here is there's all kinds of places where maybe this might break. Now, I'm going to tell you, Amazon is incredibly resilient, and their services run all the time, but everything breaks, right? Werner Vogel says everything breaks. So let's say I got great translations, but I hit Poly, that worked, but then for some reason I couldn't write it all to the bucket, and the whole thing died. So 1, I lost my translations. 2, I lost my audio files. And I've got a problem there, okay? So I've got to get back to the client and say, say, hey, let's get that again. I'm writing in error handling. I've got a lot of error handling in here to make that happen. But all right, so when it's all done, what we call the happy path, if it works, then this is what we get. Okay, so we come to a point where it's written out in different records. So what I do, in particular pattern I'm doing for database here, is that I'm writing data as each one is an individual record in the database. And I have an original, which has all the cultures. I have the audio files, and the way you can tell those are audio files is by the type. And I have the translations. Now in DynamoDB, and there's a little bit out of scope for what we're talking about today, but when you're doing NoSQL or DynamoDB, the way we have what are called a hash and a range. So your hash is your ID, or you can have the two of them coupled together, make an index or make an ID, right? So the way I've got this is, what makes this unique is the ID and the type together, and then I have a secondary key, a global secondary index called original ID, and it only writes that on the original, so that when I actually want to get this for it to show on my web page, I can scan just that small index. It's what's called sparse data. Okay, I can grab just that small index rather than scanning the whole table every time. So a little bit of database magic there. Not really, I'm just very proud of it. So, and then in the S3 bucket here, I've got files that are written out that show what those are. So let me actually show you this website. Quick one here. So that's the, and I'll put that back up in a minute, but that's the actual website we're going to go to. There it is. Okay. All right. So, yes, I designed this. I'm very proud. This is my front-end skills right here. I did the CSS, the JavaScript, all that kind of stuff. I'm not a designer. I actually started in the computer world as a designer, and I knew the tools. I know Photoshop. I'm good with CSS, all those kind of things. I'm just not very creative. That's just the truth. So there you go. That's my design. All right. So let's say we want to grab something. So let me actually switch over. Let me just refresh this. Okay, so now this site is being hosted in US East 1, so it's actually in US. And because I'm the only one hitting it, my Lambda is asleep. So what you're seeing right now is what's called a cold start. And actually that's how we were seeing. I was on the wrong page. So there we go. And there we go. Okay. So if I went to Frankfurt, it'd be a lot faster. All right, so what I'm able to do here is I'm going to create, let's go out and, I don't know, we'll go to Amazon.com. And we'll go to the blog. Okay, so I'm going to grab, let me go to just one of our blogs here. And I'm going to grab some text, okay? So let's grab this, go back to my site, do create new, go, and this might have some issues in it. Let's see what happens. Okay, I'm going to choose all the languages, so I can actually choose all the languages. And here's what I'm going to do. So again, what it's going to do before I hit translate is it's going to go get translation for each of these cultures. So there's like 20-something cultures there. Then it's going to send each one out to Poly to be translated to an audio. It's pretty good sized file or pretty good sized text. And then it's going to save it all to S3, or the audio files to S3. It's going to save it all to a database. So let's go ahead and hit this, and we're waiting. Okay, so while we're waiting, this is what our customer's seeing. So at some point, your customer is probably going to be like, is this broken? This is a synchronous call, okay? So it's blocking call. So the customers now, when we're working with them, they're thinking, this is broken, and okay, now it's done here. All right, so let's go. This is the one I just did right here. Okay, so now, oh, that's not the one I did. Bear with me. The second one? Yep, this is it. Okay, so then there. So it worked. Okay? So it's really embarrassing if it didn't work, right? So it worked. So we translated it to a bunch of different ones. Let's find the Russian. See if our translation's any good. Any good? Okay, so let's see if we've got some volume here.
Технические евангелисты часто путешествуют. И вопрос номер 1, который мы получаем от клиентов при представлении Amazon Translate, поддерживается.
Alright, why are you laughing? Did you say something funny?
Translate.
Oh, yeah. So it's not a perfect science yet, right? So, okay, but see there. So when we're working with websites, you're building front-end websites, when you have your customer sitting and waiting 20, 30 seconds, they think it's broken and they move on, generally. Or they refresh, or they what's going on? Okay? So what we need to start doing, and it's not just for websites, it's for general architectures as we're building, you want to start thinking asynchronously. What can be done after the fact while the client's not waiting or while we're doing other work? What can we do that's not a blocking call? Okay? So let's reevaluate this. Alright, so let's look at this translation demo again, but instead of doing it synchronously, let's look at what asynchronous does. Okay? So, we have several options that we can do, and I talked about them earlier when we were talking about the different patterns and things like that. I can use simple notification service, simple queue service, Kinesis data streams, or our new service called Amazon Event Bridge. Okay? So in this one, we're particularly going to use Amazon Event Bridge, and we're going to use DynamoDB, but DynamoDB under the hood uses Kinesis to handle its streaming. Okay, so what this means is that I write data. Actually, I'll just show you the demo and then it'll make more sense. Okay, I'm also going to use a trigger based off of Amazon Simple Storage Service. Okay, so let's readdress this architecture. Okay, so we've got, again, we're back to this that we talked about. So instead of us doing it all with one Lambda, here's what we're going to do. Our user sends the same data, same exact data in, and it hits Amazon Gateway API endpoint, and then the first thing it does is it writes that data to a DynamoDB. Okay? There's some things to know about DynamoDB. Number one is the minute you write the data, there's very little latency in it. It's written to 6 places. Okay? Now, the 6 places, how it does it? It writes it in 2 places in 3 of what we call availability zones. That means literally different physical places. Okay? So, when it writes that, if it only gets to like 5 and comes back, then it'll automatically underneath it sync it up. So if I lost one of the availability zones, I still have your data and I'm still up and running. Okay? So what you know here is your data is incredibly reliable now. I've immediately written the data and I haven't lost anything. So even if the rest of the thing breaks down, I don't have to go back to the customer and go, what do you want me to do again? I have that data in my system and I can write maybe a cron tab with the Lambda to come through and check every hour, say, hey, I've got this, but do I have translations for it? Okay? So the first thing I'm going to do is the data is going to be written to DynamoDB. Now, what happens with DynamoDB is it has a stream on the backside. Okay? Basically, whenever data is written to DynamoDB, it writes a stream out the back of it. It's basically a log of what's happening. Okay? And I can trigger a Lambda. I'm going to call it the stream reader. I can trigger a Lambda to do something with that. Because remember, all it is, it's an event, right? And so then we're triggering the Lambda. So the Lambda then takes, just like in the other one, it takes and it breaks out the different cultures, and it submits those jobs. It doesn't submit directly to translate. It submits those into Event Bridge. Okay? So let me explain what Event Bridge does. Event Bridge it's a bus. It's a bus of events. It basically says, here's what's going on. Here's a pipe of things going on inside of your account. Okay, you can create a custom bus. You can say, hey, this is just what I'm going to use for this application, or you can use the default one. Everybody has one. And so it's kind of like an SNS. But what happens is I put all my events into the bus, and then I can write rules that read from them. Okay? So, and I'm going to show you those. I'm actually going to jump in when I'm through this demo. I'll show you the code that does it. But it says anytime I have something that matches, grab that and do something with it. Okay? So that's what Event Bridge does. Very handy. So what I'm doing is I'm writing custom events to the bridge. And then I have another Lambda on the backside that has a rule that says, hey, anytime there's a translation request being made. So when StreamReader up here puts an event into the event bridge, it says, this is a translation request. Okay? Anytime that translation request is triggered or found in the event bridge, it's going to trigger this Lambda. He's going to do just what we said before. He's going to get a translation and write data back to DynamoDB. Okay? Anybody with me on that? Any confusion or questions? So let me ask you this. If I'm writing data back to DynamoDB, what do you think happens next?
It will send another event to StreamReader.
That's exactly right. It's more data in DynamoDB. So it sends another event to StreamReader, but this time StreamReader says, no, that's it's already come through as a translation. So what do I need to do next? I need to create an audio event. So it writes another event to EventBridge that says, create an audio event. And this which triggers this one to actually grab that data and create an audio event. Now, funny thing about Poly is, in our last event, I had the Lambda spin and wait for Poly to give me back the file, right? I don't have to do that. I can say to Poly, hey, here's the text, make an audio recording and drop it in a bucket, I'll see you later. Okay, that's an asynchronous approach to it. Okay, so what I did here is this audio, then getting the rule from EventBridge, it says, hey, make an audio recording of this text and drop it in a bucket, and I'm moving on. Okay, so if you notice, endpoint Lambda, StreamReader Lambda, translate Lambda, and audio Lambda are all very short bursts, right? Boom, did the job go away? Boom, did the job go away? It's very quick, okay? Finally, but I need to know, so once this, because I've already written the original data, and I've written the translations back to DynamoDB so far, okay? Even if Poly blows up, I have the translations in the original now, okay? So now I need to know when the files hit the audio bucket, okay? So I can then do a trigger off the audio bucket. So when I have a trigger on S3 that says, when you get a file that's dropped in here, I want you to trigger a Lambda. I want you to fire a Lambda and pass it the data. So what happens is an S3 event, it says, hey, this is my bucket, here's the bucket name, and here's the key name, the file name, okay? Now do whatever you want to do. So finalize says, okay, I know where you are, so I'm going to write that to DynamoDB, okay, as a separate record. So what you've got here is rather than using one Lambda that spins for as long as we saw it spin, we're going to use 1, 2, 3, 4, 5 Lambdas that are all quick. Okay? Granted, more invocations, less time spent in memory. Okay? 400,000 gigabytes is what you have in memory each month free. 1 million events, what you have. A million invocations. So you've got some room to play there. All right? And again, these are very quick. And there are different permutations you can do with this to reduce some of that. This is I made this to be a very asynchronous example. So let's take a look and see how that works. Let's do this to this part. All right. So on this same website, I actually set it up, and it shows the architecture if you want to look at it. I actually set it up to handle both the synchronous and the asynchronous. Okay, so now we're going to take that same data. We're going to go back here. We're going to create new. Okay. Okay, ready? Here we go. And we're done. Okay, so now, if I look here, granted, the audio rendering isn't done, right? Because it's still happening asynchronously after the fact. But my customer does not think it's broken. My customer's not waiting. They can move around the website, do whatever they want to do, and come back. Now, what's happening here? Oh, no, it's done. What's happening here? I could have done this WebSocket where I would have got triggered and it would have updated. I didn't. I just did a worker. I didn't even do a worker. I just did a timeout where I check it. I take one minute and I check it every 5 seconds. After a minute, I shut it down. Whatever I do, should be done. Okay, you see the difference in the time the customer's waiting and the interaction? Now, again, this is a website example, but you see how asynchronous tends to help out. So, and again, it's the same. You can listen to this
يسافر الإنجيليون التقليديون كثيرا والسؤال الأول الذي نحصل عليه من العملاء عند
Okay. All right, any questions on that? Does that make sense? Okay. All right, serverless guys, is this something you've ever seen before as far as thinking that way?
Yeah, can you go to previous slide?
Yeah. You want to go to the deck, to the slide deck, or the page?
Page. The slide.
Oh, the slide. Yeah, just a moment.
It's schemas.
Takes a second to figure it out.
Here, can we remove Amazon database and replace with any LDS solution like MySQL?
Absolutely. Absolutely, yeah. I tend to use Dynamo because that's what I know. Serverless does work with RDS if you want to use Aurora MySQL. In fact, there's a version of Aurora MySQL that's serverless. Aurora serverless, very cool. But yeah, you can do that. The thing with, and here's just the reality. The thing with database connection or relational databases is the connection management, right? So when and there's several blog posts that have been posted on this, because serverless is a stateless, ephemeral thing, the connection's not always a promise, right? You don't have a managed connection. So what people do, anything, when we talk about, if you remember the anatomy of a Lambda, we have a handler, right? Everybody know what I'm talking about, the handler? Everything in the handler is run every time. Okay, when you invoke it, it's run. However, if you store something out of the handler, if you write some data into memory outside the handler, there's a chance it will be there the next time you invoke. Okay? But what you want to make sure is one, you don't want to store sensitive data there, right? Because you might invoke for a different customer the second time. It's the execution environment. Okay? So what some folks will do is they'll store the connections out there, and there's a chance that connection may still be there, but it's not a reliable solution. So you do some cleanup and reinstitute the connection. There's also a thing we call a data API. And what it does is it manages the connection for you, and then you can hit it as like a REST API calls against it. A little more than what you were asking, but yes, you can absolutely use, you could spin up EC2 instances and run something like a Maria or a CouchDB or something like that if you want to. So, yeah. Does that answer your question? Okay. What other questions?
Where is this database should be hosted?
Say again?
Where is this database should be hosted? Only in Amazon?
DynamoDB is absolutely just it's in the cloud.
But if I have my own instance in my organization, is it possible to connect?
Yeah. So how do you do that? You can. So what you want to do that is you can do what's called direct connect, or you can do a VPN so that you're connecting through there. Problem is you can have.
After new database will come to my database, who should trigger Lambda?
Okay. Back to your, I see what you're saying. You know what I missed? So what you're saying is, will this trigger off I'm going to come back to you. I think you're both on the same link and I missed it. DynamoDB has a stream of triggers, okay? With what if you're using Aurora or MySQL, something like that, there's some manual effort that would need to be done on tree. I missed that part of the question, but that's what you were driving at, wasn't it? Yeah, okay, so I missed that part of the question, I'm sorry. No, they don't have the stream, so there would be some manual work that would have to be done. What you could do is you could do Dynamo at first, but let's say, hey, I want this architecture, but I need my data to be in like a relational. You could write to a relational out of the stream, okay? So DynamoDB could be your fast I/O, okay? Things are getting written, everything like that. But after the final one, you could trigger an event bridge again and write data out to a SQL server. Does that make sense?
What is this manual work?
Say again?
What is this manual work?
Was this manual? Oh, the manual work. Well, so like depending on the database you choose to use, you would need to somehow trigger, like you pull it for changes and then trigger something, rather than getting a stream like this. So this makes it very easy to just automatically happen. But you'll pull for changes. But my suggestion would be to write to this and then in the end have it, the last trigger writes to you. So, did you have another question? Okay. All right. Okay, good. Well, I completely glazed over when you said that. Yeah, I was like, oh, okay. All right. So, let me ask, what if we want to add another step? Okay. So, we've kind of talked about breaking these down, doing them so that we can do it, in an asynchronous way. This pattern makes it really easy to add more things. Okay. So, for example, I want to get sentiment analysis. So meaning, with Amazon Comprehend, I can analyze text and figure out if they're mad at me or if they're happy with me. I take every text my wife sends to me and I run it through Amazon Comprehend. It helps a lot. You really can't do that. You can figure out what is the basic attitude of the message that's coming through. So I can do that. So what I can do is, this is back to our architecture, I can simply add in another string or another rule. Okay, I could say, okay, add another rule that triggers a sentiment lambda. That lambda should go to Amazon Comprehend and grab the data and then write it back to the database. Okay. Real easy. See, all the architecture's here. The other way, I would have had to go through all the code, and I would have had to, add another, especially if you're doing Node, I would have had to do another callback or a promise or something crazy like that to add it in. But in this, so what you're looking at, and I'm actually going to show you code on this, but what you're looking at is very small bits of code to make this work. Okay, rather than just small in relation, but rather than 300, 400, 500 lines on Lambda. It's all broken out into separate ones. Questions on this? All right. Yeah.
From that thing, we saw a web page that showed us at some time an audio file. How was it implemented? It was JavaScript on that page that tries to pull new data to this.
Oh, my website?
API.
Yeah. So the website is.
We see here only the first request, just to make work done. But then how my browser gets the result?
Okay.
Every single audio file.
So and that's a good question. What I'm not showing up here is down in this blank area is I have what's called a get endpoint. So that's my post endpoint. Everything going through. I have a get endpoint that just reads from the database, and it just does that small, that secondary index to grab the main data. And so my browser just pings that about every 5 seconds, just to see if there's new data, and then it pulls it down. Yeah, and I should represent that here. I'm sorry, I forgot about that. So, all right. So with that, let me jump in here real quick, see where our time was. Okay. Sorry, 1 second. Yeah, so we're supposed to be in a 2-hour workshop, so we might end up going to this one. All right, so when you get into Cloud9, reload this, make it log in again. Anybody have access to their account yet? Bear with me 1 second, folks. Alright, so. What I'm going to do is I'm going to grab this. So what I'm doing is I'm grabbing copies of that code so I can show it to you real quick here. Okay, and I have several repos that do this. And finally, all right, that's it. All right, I asked earlier, but I didn't hear it. Does anybody have, if you've got access to your account, can you raise your hand? Still nobody has access to it. Okay, 1, 2, 3, 4. No. What's that?
I still can receive a key, access key ID.
Still waiting? Okay, yeah. All right, so we can't do the demos yet. So I want to take a moment to kind of show you what these applications look like. So the first thing we've got here is we've got the let's do the async or the synchronous backend. Okay. So the way a serverless is this big enough? Oh, hey, you can't even see it. Can you? Oh, wow. Close this. Sorry, I thought you guys could see what I was doing. There we go. Let me see if I can find the light turns off. That's hard to see. Oh, wow. Hey, I didn't tell you at the beginning, usually I do, and this will help. I have a couple of rules when I'm speaking. Rules are probably strong, but this will help. First one is, this is any number I want it to be. So you guys have seen me already today going 6, or 5, or 92. So I hold one finger up when I say whatever number I want. Doesn't work well in restaurants. More, I'm at the table for 7, I'm alone at the bar. So these are apostrophes, not quotes. I do this a lot. I'm sorry, these are quotes, not apostrophes, and these are thumbs. You'll see me do this too. So you see me doing that, that's kind of what I mean by that. But All right, so y'all can see the code up here. So this is the basic idea of what a Lambda app or a serverless application looks like, okay? So in this, I've got my template file, which I talked earlier about my infrastructure as code. So this template file describes my application as an infrastructure. Let me just talk you through this real quick. First is I have a global section. It's not really important at the moment, but we'll talk about that a little more in a little while. The global section says, hey, for all functions, I want to make these certain settings. But the main thing I've got here is I'm creating a bucket for all my audio files to be stored. That's all I have to do is just say create an audio bucket. This is the logical name and of the type, and it'll create the bucket. The second thing I'm doing is I'm creating the function, and I call this the process function. Okay, and the parts of this are I tell it what it is, so it's a function, where my code lies, which is under the process folder. Okay, the timeout, I gave it 45 seconds because I knew it might take a while. Normally it's 3 is the standard that I do, seconds. And then I do policies. Now policies are how we do security in SAM on Lambdas, okay? So these are managed policies, and we have a website that I'll give you a link to that show what I'm able to do is I'm able to say I want it to have DynamoDB CRUD policy, CRUD being create, read, update, delete, okay? And I pass it a table name. But notice I'm not doing a hard-coded table name. I'm doing a reference to the table that's being created down here, okay? So in this, essentially what I'm getting is I'm saying, create a table, give me the name of it, and then I'll write a policy that lets me do create, read, update, delete from that table and that table only, and just this Lambda. So it's very granular security inside of SAM. Someone was asking me earlier, how do we protect? This is how we do it. Okay, I can add different. This particular Lambda needs to read and write from Dynamo, read and write from S3 bucket, and then I'm doing a custom statement because I don't have a managed statement and on what I want it to be able to do with the different language apps. The final thing I'm doing is I'm giving it the event. Remember, I told you when we build a serverless application, you have to have an event that triggers your Lambda. And right in SAM, I can tell it what event that has to be. I'm telling it should be an API. And you were asking me earlier, how do I run? This is how. And I'm going to show it to you in a second. It should be an API. And then I'm going to pass some properties. I can pass a lot more than this, but basically I'm giving it the path that I want to do it. I could actually, put, translate here, and it would actually use that path instead. And then the method that it should do. I also globally enabled cores so that it would be able to read and write cross domain. Some other things that I'm doing globally, I do tell it the type of runtime. I'm using Node 810. I turned on, remember I said earlier we were talking about X-ray, I turned on X-ray. Now, one thing to notice, I did a global handler on a timeout of 3, but I overrode it in the actual function of 45. All right, finally, this is my table. Now, I'm doing really, in order to do a table, all this that's highlighted, I don't have to have. If I just pass these 2 lines, 69 and 70, it'll create a DynamoDB with a ID of ID, and that's it. But I wanted to be able to use that. Remember, I was talking about the hash and the range and everything like that. So I added those, and this sets all that up for me. Okay, so that's the template. Again, I know that's kind of a lot. As far as the code, let me show you what the code looks like. So it's about, it's not horrible, it's about 129 lines of code, okay? And you can walk through this. This is the handler. I've got some external functions. Here's the record creator, here's the get translations, here's the get audio, here's the save audio. So I've done some different things there. So it kind of gives you an idea of, what I'm doing. If you know Node at all, you and I know I'm going kind of fast, but that's how it does. I'm also including, excuse me, I'm loading up some different data that I need. I have an AWS SDK. Now let's compare that to go into my asynchronous. Now I have a bunch, each one of these folders is a Lambda, okay? So one, like I said, there should be 1, 2, 3, 4, 5. Now we have 6, 7 here. One is the sentiment that I added. I told you there were 5, but there's actually 6 when we add sentiment, and then my fetch, what you were asking me about. This is how I'm fetching that. This is my client. So in the original endpoint one, okay, I have 29 lines of code. And that's all it's doing, is just writing code. Or it's writing that data to the database really quick. So then the next one I do is a translate one. And that's a little longer, it's got 43. You add these together, you probably have a little bit more because I am loading the dependencies multiple times. Does that make any questions on this? This is kind of what the code looks like behind the serverless application. I'd love to answer any questions or any observations. Nothing? Okay. Does it make sense, or is it just like, I don't even get it? Okay. Y'all can hear me? All right. Let's see. Okay. So, let's see what it actually built so you can kind of see it. I'm sorry, I keep clearing my throat. I don't know what's going on here. Okay, so the first thing, let's look at the API gateway so you can kind of see that, see what's happening. So I'm in the Oregon region because that's what this application is. Everything we do is region specific. So you see I've actually got 2 separate APIs. So I have the translator async and the translator sync. And this is for something else that I'm doing, we might look at later. When we go in here, you can actually see there's the resources that, and remember, it's just that simple line that said, in my event, create an API with a /. That's all I put. And then enable CORS, and it gave me an options endpoint. How many of y'all are familiar with CORS and had to wrestle with CORS? Okay. CORS is cross-origin resource scripting, I believe. And what that means is, front-end development especially, is the biggest headache in the world. And you want to put your head through a wall sometimes. But what it does is browsers are very specific about where they'll call data from. And so if I want to call, like if I'm on, a front end that's, mydomain.com, and I'm calling a backend on mybackenddomain.com, I have to add some tags and some headers that have to happen. And the API gateway will handle that automatically for you to a degree. You have to, like I just did simple. If you see in my course, I just said, hey, let any domain and any header work. Probably not to say this. I can go in and customize that to say just these specific domains. And I can do that through SIM. So yeah, CORS can be a real headache, and it can be a real challenge, but it is a part of life that we have to deal with. Excuse me. Okay, so on this you can see where you're posting. Guys, I'm sorry. All right, so I'm posting. You can see the method request. I'm not going to go into all these, but you can see how the API gateway was given. Here's the get function. I have no security wrapped around it at the moment. If I wanted to add authorizers, I could. I can add models. Yeah, I can do all kinds of things with API gateway. A lot of power there. So the second thing it creates is a DynamoDB table. And I have 2 tables that it created. I have the async table and the sync table. So in the async here, you can go into the items, you can actually see them right away here. So there they are. And this shows how everything's set up. You can look at You can even look at, it's kind of handy, when I go into the overview, here's my stream. If something were going bad and I had a loop or something really bad going on, I could go in here and manage the stream and I can disable that stream. So data would still continue to get written, okay? But it wouldn't, I wouldn't lose it all. I could start it back up and then then my system would continue. All right. Okay, and you've already seen the Lambda. All right, so let's go back to the presentation. I want to talk about a couple things. So, other advantages to building this way. Okay, we're gonna climb into more Lambda, but what do you guys think? Throw out what do you think? Do you see any advantages or disadvantages to building this way?
It's very reliable, but it's hard to bring this down. Business scale.
Say it. It's reliable, but
It's very reliable, but it's hard to prepare architecture for all this microservices.
so if I understand, it's reliable, but it's hard to prepare that. Okay, some truth to that. That's why, but if you think about when we're doing infrastructure as code, rather than that's when you saw my template, it is as simple as adding another template and deploying. So I manage that through the, I agree with you. Enterprise applications are complex. I mean, there's just no way, there's no two ways about it. But the reliability, you got Cloud9 up and running, right on? Okay, good. All right, anybody else getting Cloud9 up and running? Okay. All right, but the thing about this is, and I agree with you, complexity sometimes when you're separating them out. The cool thing here is I could add another Lambda here, and his entire job would be to check my database for what exists versus what should exist. Okay? So I can write in some self-healing application logic here that manages this. Okay? Now this is a translation app, and the idea behind it is we're actually writing it for for a zoo, and we wanted them to be able to put in text and have it like, "Hey, welcome to the panda bear enclosure," you know, and then it would put it out in any language. They could print it and have a button that you play it. Okay. So as people put it in, we want to be able to say, okay, is everything there that should be there? So I could write a Lambda that scans. And so one of the things in this, and it's written into this database, is when this translate, the very first Lambda after the event bridge, when translate hits the event or hits the translate API, if it fails, I still write back to the data. I write a record to the data, but in the translation text, or I could add a separate error field, I write the word error. That's simple. Okay, then what I can do is I can scan the database once an hour looking for errors, and then I can do some self-healing. Okay, try again. If it doesn't work, then let's notify somebody. So reliability, hugely reliability. Complex, yeah, it adds some complexity, but that's our job, right? I mean, when people talk to us as developers, we can't push back and go, yeah, that's too hard. Reliability, look, I want simplicity in building. Now, I believe that this is simpler than building in some of the frameworks that we have to build in, especially monolithic. But the reliability part is huge. So, yeah.
What about reliability of DynamoDB? It is the main point, which
It is.
and broke everything.
Yep. So DynamoDB, it is an SLA. Don't quote me on this, but I have to look it up. And I believe it's 99.99 uptime, percentage of uptime. And so that's availability. So let's talk about important metrics. The two we are thinking about is available and durable, right? Okay. So availability says, hey, I can get to my data. Okay. Durability says, hey, my data still exists. Okay. And you ask which is going to make the customer mad. You come to a customer and go, hey, you can't get to your data right now, about an hour you'll be able to get to it. They're going to be mad, but they're going to survive. You come to your customer and say, hey, we lost your data. That's a whole different story, isn't it? Right? So the first thing about DynamoDB, again, the durability is we write, when AWS sets up their architecture, we have several things to think about. We have what's called a region, okay? And a region will have multiple AZs, okay, availability zones. So a region will have 3+ availability zones. US East, the first one that they did has like 7 availability zones, okay? An availability zone is not one data center. It's multiple data centers that are interconnected to provide uptime and redundancy. Now, when you're on a Lambda, your Lambdas and let's go back to DynamoDB. When you're in DynamoDB, when you write that data, it's going to write it in 3 availability zones in 2 different places. Okay? So durability is incredibly strong. It also is backed up frequently to S3, which has 11 nines, so 99.9999. I've already lost count. That many nines of percentage uptime. It's the highest SLA you're going to find, right? And so that's the durability part. The availability part says my data. If I lose a data center, I'm still up and running. Even if I lose, you can do one of the cool things. If you really need, so let's say in your head you're thinking, okay, that's great. 3 data centers are in one region. That's where my data is written. What if that whole region, God forbid, gets blown up? Okay? And I don't mean blown up like a bomb. I mean, I don't know, something bad. I'm not trying to introduce something scary here, but we lose a whole region, right? Number one, your data's still safe. But you're like, yeah, but I need availability. DynamoDB offers something called global tables, multi-master global tables. So what happens is when I write to this, it uses strings to automatically sync to another region. And it syncs it up. So I can write here and I can write here and it syncs them up. Okay? And so you have global, so let's say I'm doing that in US East 1 and EU in Frankfurt, EU East 1. Okay, so I have data both there. So US East goes down, Frankfurt's still running. Okay, so maybe some interruption on people trying to get to the data. Data's still there, but then it'll start traversing over there as well. So hopefully that answers your question of, yeah, that is a linchpin, but durability is incredibly high there. Yeah.
What if Amazon DynamoDB will send event to stream reader? It will push event to Amazon Translate, but it will be not available. Won't be available.
Right.
Resend event.
Right. So first of all, DynamoDB is not doing the sending to the stream. Charging the stream reader. I see what you're saying. So you're asking, what if the Lambda's not available?
Lambda or something later after the
Right, okay.
Delivery of event.
Right, okay. So it will sit in the stream until something is grabbed and said, yeah, I got it. And it'll stay in that stream. And the stream is backed by Kinesis, which I was talking about earlier. And Kinesis is multi-redundant as well. So not just the data that's stored in Dynamo, but in the stream is multi-redundant.
So stream reader will tell back to DynamoDB that he received the message, and from this time it is the responsibility of stream reader to control.
Right. So great question. So your basic question is, what happens when things break? Well, yeah, right. So, and that's why this is more reliable. There does come a point, it's like, man, we try really hard not to lose data. But so that's why the very first thing I'm doing is write the original to Dynamo. Okay? So I have that original data that everything else is built on. Okay? But you're right. So I go to StreamReader and Event Bridge is down. Okay? And StreamReader tries to fire it. So there's 2 things to look at in the Lambda. So one is the Lambda service. Did the Lambda service execute the function properly and get a 200 back? That's going to happen almost every time, 99.997, I think. All right, those numbers I don't remember well. But the second part of that is, did your code execute properly? Whereas Lambda, the function, the service did what it was supposed to do, but your code was not as good as it should be. Not mine, of course. Mine's perfect. I tested in production. But your code, I can tell you're not. No, I'm just kidding. You're probably a much better coder than I am. But if your code failed, well, that's up to you to deal with the error, right? So you got to go, I failed. So let's try this again. Let's write something to CloudWatch. Let's post an alert, and then we'll alert off that and grab it. Let's write the data out to an SQS queue just somewhere, something like that. But if Lambda tries to, if the service tries to do it and dies, it will then retry. There's a retry error of, I don't remember the exact, I can get the documentation, but it's like 24 hours where it will retry several times. And it'll hold on to that. If that doesn't work, then you can drop it into what's called a DL queue, a dead letter queue. And it's just a queue that sits there and collects data that something happened. And then you can read that data. So there's a lot of redundancy built in to help you not lose that. But at any point, so here in step 1, we gathered the data in DynamoDB, we had the original. Step 2 happened fine, we wrote the data back, but step 3 crashed. Well, that's all right. We've got step 1 and step 2, so we've got all the data we need to recreate step 3. It's almost like an event sourcing pattern, if you're familiar with that. Rather than, yes, and that's the way the data is written, is event sourcing, rather than, and I'm constantly writing rather than updating. So it's a good pattern to be able to play back if I need to. Does that answer your question?
Almost. I don't really understand who controls all this backup process.
All right.
Control process of event.
Okay. All right. Who controls the process? Good question. Let me get a drink. So, as far as firing the Lambda, okay, you hit API. Let's just start from the beginning. You call the API. You control the call, obviously.
Yeah.
AWS's job is to make sure API gateway does what it's supposed to do and pass it to Lambda and trigger the Lambda. Okay? So we control the execution of the Lambda, not the code inside the Lambda. We just say the service itself will execute and get a 200. Okay? Your Lambda will execute and hopefully get a 200 as well, or maybe something else based on what your code does. Okay? Moving forward, writing to DynamoDB. You're in control of the writing of the DB. We have an SDK you use, and the Lambda will make those calls, but you have to do the right code to write that into DynamoDB. As far as storing durability, we're in control of that. Okay? We're going to store that data. Also triggering the stream. Having it drop into the stream and trigger the next Lambda, we'll control that. Okay? So that takes us to Stream Reader. So we've controlled, once you've dropped it to Dynamo, we'll make sure the Stream Reader happens. Now, every once in a while, you might go, well, it didn't trigger. Got to make sure you have permissions for it to trigger. Okay? Permissions are all about everything. So one of the things you saw when I was showing the read and write, there's making sure that and if I write in there, if I want this to trigger this, SAM will, when I was showing the SAM templates, that'll handle it. But if you were doing it by hand for some reason, you got to make sure that's in place. Okay. Once I hit Stream Reader, again, we'll invoke the service. Your code runs. You go to Event Bridge. Now, after that, so as far as translate getting triggered, it all depends on the rules. I said I would show you the rules. Let me show you that. So the idea of the rules, and mine are very, very simple, actually. I'm going to show you in the actually in the SAM template on how that works. Okay, so where am I? Translate AC back in. Okay, in the template, stream function, translate function. Okay, so here's the event. Okay, this says this is what I want to trigger this Lambda. This particular Lambda is the one that looks for translation calls. Okay? In this, he says the type is a CloudWatch event, so he knows what's going to happen. That automatically ties him into CloudWatch. Then he says, here's the pattern I want you to look at. The source should be DB stream, and the detail type should be translation. Now, if you notice in my stream reader, I'm actually writing, this is actually this is the function that builds the event. I write out a source and everything's DB stream. So that basically ties it to this application. And then I write out the, what else did I say it had to be? Oh, the detail type, sorry. And then the detail type, I pass in the type to match which one I need. Okay, so that's how I make sure. Everybody kind of makes sense, or y'all glossing on this? Glossing means glazing over, like, hey, we don't care anymore. That's all right. Okay. So that's how I make sure I'm in control of what events will get triggered by what through event bridge. Amazon is in control of piping those through. Yes, sir.
Sorry.
Yeah.
Not clear.
Okay.
If Amazon Translate is out of service right now, will Translate on the try to get and get the response again and again by itself, or it will just return the error code?
It'll return the error, and you have to deal with it because that's an error.
This is my logic in the application.
Yes.
To deal with it.
That's right. That's exactly what. Did you hear that? Because I know you're asking back there.
The
So
error happened in Translate service, or some service will travel back through all lambdas, which was taken this service.
Yeah. So let me explain to make sure I understand. So that's right. So your code is going to call Amazon Translate. Okay. For some reason, Amazon Translate's not available. So you're going to get a 400 or a 500, depending, instead of the standard 200. Okay. So what your code has to do is say, sums up, something wrong. Because it could be translate, it could be translate, it could be your code, you know, something like that. It could be that you were given the wrong parameters and it fired back. But if translate does not exist, then you would have to deal with the error in your code. And so my recommendation is write back to the database anyway and say, found an error or error here. And then later you can pull that and say, all right, let's try it again. All right, now we've tried twice now, let's write out an error. Or you can write an error right away. So, but that would be something you would handle in your code. Does that clarify? I know I don't want to just talk to everybody. Any questions on that? All right, did that clarify you guys? Okay. Okay, all right. Okay, you have that. I'm going to take your answer for now, look, but I'm not sure I believe you. Which is okay, I'm all right with that. Okay, so does that kind of help understand who controls what? You control a lot of what goes on in serverless. When we say serverless, we really just deal with their services. They're managed services, right? And you take part of the services. Sometimes you control the infrastructure that's set in them, like a Lambda or an event bridge or stream reader. Sometimes it's just a service you call, like a translator or a comprehender or call. So a lot of control here, no servers to manage. That's serverless. Kind of in a nutshell. If you go away with nothing, you kind of get that idea. And that's serverless whether you're on AWS or GCP or Azure or IBM. That's all we're offering right now. But obviously they're not the same service names, but that's the idea. Okay. Anybody interested in starting to do something like this? Okay, a couple of you. All right. Any of you looking at it and going, that's too hard. All right. Okay. Or any of you looking at it and going, my company will never take that. That's something we see as well. Yeah. So, all right. What other questions can I answer before we move on? We're coming up on, I think we might do an early lunch. Let me get this. Can all of you check to see if you can get into your account? Still not doing it? I see some frustrated shaking heads. Yeah.
Some functions are open, some not.
Okay, all righty.
Cloud 9 is open, but
So Cloud 9 is all you really need. Okay.
Same here.
Wait, before you move, can I read that? Oh, well, yeah, actually, no. Hey, go back to Cloud 9. So, yeah, hit that button right there. All right, yeah, so create. So what Cloud 9 will do, yeah, is it'll, so try to create an environment. And just go, just click it. Okay, and then just take it out. Take default on everything. All right, next step. So, so still not there. Anybody able to create Cloud9? You were able to create a Cloud9, right? Were you able to create a Cloud9 instance?
Yes.
Okay. Should. Yeah, you're in. Should. Anybody, you were not? You're in? Okay. Anybody else, Cloud9? Alright, so, alright. Well, okay, so here's what I think we're going to do. If you don't have any questions, and anything else I can answer. Alrighty? So, what I've got, I can talk all day. I just don't want to bore you guys. Okay? Anybody bored yet? Be honest with me. I figure some of you be honest. Alright, good. You're not bored. Alright, so what I think we'll do is, let's end this, and then I'm going to have them, I'm going to tell them we're going to go ahead and do lunch. Y'all hungry? I'm hungry. And then I will get the next thing set up, and then let's see if we can do. Again, and I want to stress, if you didn't catch this when I said earlier, if we don't get to the workshops today, you can do them at home. They are absolutely self-driven. And you walk through and it'll tell you exactly what to do. You won't have me here to answer questions, but I'll give you well, you've got my Twitter here. Hit me up. I answer. Sometimes it's like, hey, it's the middle of the night here. Leave me alone. But most of the time, it's like, yeah, I know the answer to that, because I'd love to be the guy to answer questions. So, if for some reason we can't do the workshops, don't sweat it. You'll still have access to the workshops. I won't take them down. They're on my actual, my GitHub, and you can just walk right through. The workshop that we're going to do is called Wild Rides. Like I said, we call the unicorns. It's a standard AWS one that we do. So getting support on it's not hard. So we can definitely, and before we go, I'll explain exactly which ones to do. Make sense? All right, I'll call her and tell her, hey, we're ready to do lunch. Because it's too late to, I don't want to start another session yet, but I've got some other sessions we can walk through. Hey there, I think we're ready to do lunch if you guys are ready. Does that work? Okay, sounds good. Thank you. All right. So I'll put this up if you guys want to, real quick. So that, if you want to mess around with the application, the translation application, this bit.ly, or anywhere it's mobile as well as notification QR code. Love to get your feedback, see if you can break it. You probably will. I didn't put a lot of redundancy into it, but it should be fairly solid. So that's the serve-translate is the one that I've been doing it. One thing I will show you here. She's going to come down in just a minute here. So remember I said, how easy would it be to add just another service? If you go in here on the asynchronous, see here the sentiment neutral? So on this one, it's that, and I can put in here, let's create a name. All right, so let's translate this to everything. So notice that it doesn't have, there it is, I got a positive. What's up? All right, now, I need a volunteer. Come up here for a second. Come on, somebody come up. Come on, yeah, I knew it'd be you. Come on. Tell me your name. Tell it to me slowly.
Vlad.
What's up?
Vlad.
Vlad. There it is. I don't hear very well. All right. So I had something in Russian here. can. I don't know if my keyboard will do what you need, but so. Yeah, there's no Russian. Here, all right, we'll grab some Russian and paste it. We'll do that. So the way this works, yeah, that makes more sense. Sorry. Okay, let's see if we can find. All right, here. We'll just take one of the ones we took. So the way this works, it's kind of cool. Okay. All right, I'll miss you, Vlad. Okay. So I haven't actually tried this. I'm pretty sure that I wrote it this way, but let's try it. So now we're doing Russian, and I want English US. Okay, let's translate. Boom. So this uses in the background, I can set the language that I want to translate from, but I actually went a step further, and I told it to check comprehend, use the comprehend service that we offer, take the original phrase, tell me what language it is. So now I can pass any language in, maybe not any language, but like 30 or 40, a lot of them. And it'll translate to any other language. A lot of control, the way the services work. Very cool service in anybody work on, I think you did training stuff, right? Anybody working on like customer service type applications? No? Okay. All right. We have an application that we wrote where customer service, where we use Pinpoint, which is our phone service. You can connect in, and as people are talking, we translate it to text automatically. And then it automatically checks it to see, hey, they're happy or sad. It has this little meter. It says, hey, they're pretty mad at you. Oh, do they like you? Hey, they're mad at you. They're neutral, that kind of stuff. So it's kind of helpful for customer service because they say, oh, okay, I need to take care of it. So just kind of fun, and it's all streaming. So, yeah. Whether I want to see if the English plays.
Hey, I love you. You're the best. Everything is great.
And let's see if we got the sentiment. Yeah, see, it read the sentiment off the Russian as well. All right. All right. Any questions on that? Any questions on how you can do this better or what I can do? Any comments? Come on, developers out there. What would you change?
What's the main advantages like creating web applications with Amazon Web Services? I see like managing infrastructure.
Yeah.
And maybe a lot of service, Amazon service, like translate and like that.
Okay. So what's the advantage to
Yeah, because like I can create web application with 2 clicks, like in .NET or Java.
Okay.
It's easy nowadays. So yeah, I don't see the advantages.
All right. So actually, that's a great question. Okay. So if I understand, I'm going to repeat back to make sure. Why would I go to AWS if I can do this right in .NET? Okay. Some of this you can't do directly in .NET. You use a service, right? Translation service, something like that. So the reason. So let me tell you kind of how AWS approaches this. Okay. So first of all, we were infrastructure. Infrastructure is a service, right? And we don't classify ourselves as an IaaS provider, but that is one of the things we do, right? So we came in and said, look, you do the code, we'll give you the infrastructure to build it. Okay? Well, one of the things, what you'll notice is our roadmap on almost everything we built is directly dependent on what customers tell us they need. Hey, we really need this. Hey, we really need this. And one of the things is the need for machine learning or artificial intelligence without having to write it. You know what I mean? So, hey, I need to be able to do a quick translation. All right, well, here's an API to do it. Google has one also. You know, if you do their APIs. Right? So I need to change text to voice or go the other way, voice to text. Okay? So, and rather than, and yes, I don't know the language that do them internally, like .NET itself won't use the service, right? But it's not part of the framework. I'm asking, I'm not sure, so. What's that?
Again, your question.
So if I'm doing .NET, Right in the framework, I can't translate text. Right? I use a service. Right. Okay. Yeah. So this is a service to do it. But the reason, so building on top of that, we also have a thing called SageMaker, which actually does machine learning, that you can actually train it, but it does it in this style. I mean, it really brings machine learning to those of us, like me, who don't understand machine learning. It allows us to have the power of that without having to understand what, the notebooks are and what all the, all the kinds of things are. But you can get deep into machine learning on AWS as well. The reason we say use AWS instead of something else like a Google or a service like that is, one, we have it all together in one application or one cloud service, right? So it's all together. We've been doing it longer than any of the other clouds. We have the broadest, and this is not me just quoting marketing facts, it's fact. You go and look at the dashboard, and you'll see our services are much broader. Google is an amazing company building amazing cloud. Microsoft amazing building amazing cloud, but they're not near as far as we are. In fact, Google's, I'm a developer advocate, that's my role. They have a developer advocate, his name is Kelsey Hightower. Super smart guy. You know who I'm talking about? Have you heard the name? Okay. Anyway, he's the one who made earlier I was talking about the custom runtime layer in COBOL. He's the one that did it. Because he wanted to try out AWS Lambda, and even he said, this is the gold standard. These guys are knocking it out of the park from what they're doing. So, and I know it just sounded like I was just doing a big marketing pitch, and that's not what I'm trying to do, but the advantage with us is you have more services. They're automatically all under our security umbrella. So the IAM, the Identity and Access Management, is going to apply to all of them. You don't have to go to this company for this service, this company for this service. Do their security here, do their security here. It's all rolled into ours. Our SDK interfaces with all of them. So if you're using .NET, the .NET SDK is going to be able to interface with all of them. Node, Python, Java, whatever. Also, the reliability and redundancy that we built in. I'm not going to say we don't put down, everything goes down. We build for reliability. Here about a year, and you guys may have never heard of it. Do you have Netflix here in Russia? Okay, you watch. I know it's a dumb question, but I never know. So you have Netflix, okay? So Netflix, this is a great story. So about a year and a half ago, S3, the one I was talking about earlier, part of it went down. Come to find out, someone fat fingered, literally, where they hit the wrong button, and rather than doing two things, they did 200 things. And it took part of it down, not all of it. Because remember, we're segregated in regions and availability zones. Problem is, it was one of the major ones. And we had people all over the place saying, oh, Netflix went down, or oh, S3 went down, everything like that. Netflix uses S3 for a lot of their stuff. And they use serverless for a lot of their stuff. They never went down. Because they were duplicating, like we talked about, out to different regions. Okay, our infrastructure is crazy solid, and we have high maintainability and high recommendations for building out. I don't know if that answers your question. I mean, I can continue to tell you things, but the advantages are just that, So, am I missing the question, or does that make sense?
I'm trying to figure out. So it's more about like public services. So you can't like create services for inside your company without like internet or something like that.
Okay, yeah. So you can't run AWS locally. No, it is a cloud, and it's designed that way. It's not a.
You don't do it even for like corporations, like big companies. You don't do it even if they like request and not request.
So we don't. We tie in. I'll tell you what we do, and we see it a lot. Is we tie in. We do hybrid. We don't do it. Our customers do it. So we are just cloud. That's all we do. But our customers will build hybrid architectures that have some on-premise. Because one of the things, and I know you deal with it here in Russia, is data sovereignty. Meaning data has to stay here. It has to be here, not somewhere else. And so what they'll do is they'll store their data in a local data center and then do the compute out on AWS, like through serverless or EC2, which is virtual, and they'll do that out on the cloud, and they'll have a direct connect, big old fat pipe to handle that. But the bottom line is no, we don't do on-premise architecture. We just do cloud. But this service here is a, I'm connected. Now I don't have any, you can all go out and play with this because I haven't done any authorization on this. I could. I'd go out and slap it on there, then you'd have to log in to do it. But it is, it's like it's HTTPS, it is secure socket. I could tie it down so that it's authenticated. So I could, and then I could run it and I could access it through a VPN, right? So I could really lock it down and make it just usable for my customers. So people who do like the customer service one I was talking about earlier, they would do something like that. This is open for anybody to use. So, yeah.
What about data security? Could someone from Amazon, for example, get access to my own data from my own service?
Yeah. No is the answer. Yeah, that's a great question. Yeah. Sorry, I realized, read all your data. No, we do not have access. So the top things that we work with, or the top priorities are security and privacy. And so Amazon, and AWS is part of Amazon, we don't read anything. We don't look at anything. Now you have seen in the news things like Alexa, are we listening to you, things like that. The way Alexa works is you say, hey, Alexa, and then it comes on, and then it listens to you. And yes, it sends that data to the cloud to analyze and use the machine learning you've seen up here, and then it responds. And there, in the checkbox in the usage rights, it says we will learn from that, so we'll improve that. But you can opt out of that. Other than that, we don't read data in your S3 buckets. We don't read data. We don't have access to it. It's not that we just don't. We don't have access to it. You can actually, if you want to say, hey, look, I want to make sure there's a couple things you can do. You're like, look, Eric, that's great. I love what you're saying, but I don't believe a word of what you're saying. So I'm going to make sure. Number one, you can encrypt all your data. And you can encrypt it, before you put it in. Now, we have some tooling that allow you to do encryption at all times. DynamoDB it's not up there. If it were there, I'm pointing at it. DynamoDB is automatically encrypted at rest and as it's transferring out. So that automatically happens, and it can be a rolling key. But you can set it up where you manage keys and we never even see them, or you can put it in our service so that it is managed. And when I say we, I mean our automated system. I don't mean I'm there going, key. I'm not doing that. But if you still think, that's not good enough, you can actually encrypt it as it's going in. We don't read data. In fact, we encourage folks to encrypt their data. If the government came to us, and this is true, if the government came to us and said, hey, for criminal reasons or whatever, we need to read that. Okay? What we would do, this is how we approach that. It sometimes, it depends on the country you live in and stuff like that. Sometimes we have to abide by rules like that. If at all possible, we notify the client first. Hey, we've been requested to show that data. But we tell everybody to encrypt your data. Because if the government came to us and said, hey, we want to read that, there it is. Good luck reading it.
But how does it manage it? Because if you execute my data code on your cloud, then you have access to all the memory, all data from the
So
all secret from it.
Yeah. So I have access to I still don't read this, but we're talking about code versus data, right? And you're right, the data goes through the code. You're right, and we don't look at that, we don't touch that. So again, if you want to be secure, you could, this is obviously extreme. You could encode a client side and push it that way.
Yeah.
So that's obviously, and obviously using TLS, SSL.
I can't process it in Lambda because I can.
You'd have to unencrypt. Yeah, exactly.
How
So
can you get that data?
Yeah, you're right. So and this is where I have to go. You got to trust me on this one. We don't analyze. We don't look at any. We don't read the data going in and out. We don't read the packets. We don't do anything like that. And we have dozens of documents saying it and dozens of clients. In the U.S. and this may not mean a lot here, but in the U.S., CIA uses it, and that's something. I'm not telling you any secrets. That's something that they'll tell you. We have Department of Defense. We have different people who use this because of our stance on security and privacy. We absolutely don't read data. and we go to the end to not read that at all. So hopefully that answers your question. That's about the best answer you can get to. I mean, I wish I could do more than we don't, but we don't. And then there's a lot of security you can wrap around where you control the keys, you control the encryption, things like that. So
I just want to know if is there some technology to guarantee the core privacy, or it is just word of Amazon?
It speaks about the memory inside. So,
yeah.
server side. Okay, this is encrypted.
Okay.
This is encrypted.
Yeah.
Possibly client side.
Well, client side's you, yeah,
But the server side.
but the server side,
should be
yeah.
should have the raw data. So this is the memory, and there is a possibility that. And he asks if do you have some technology to make the memory even more secure?
So like I said, on most of our services, we encrypt in transit and rest. When we do the way, so Lambdas run in what's called an execution environment. Okay, it's not a container. I think it's like a container, but it's a hyper small, hyper fast one. We use a technology called Firecracker. It's open source. You can read about it. And it's isolated memory, isolated storage, isolated everything. So there's a VM, and then here's the execution environments are all locked in and they're all isolated. Okay, when that's torn down and thrown away, the whole thing's gone. Okay, so it's not something laying around that someone could get a hold of, pick up, or virtually pick up and read that memory to life. When we do, and some things, it's that under the hood, there are things we can't talk about. But I can tell you that when we if you're using like EBS, EBS is elastic block storage, which is like storage for VMs, something you can attach, detach, attach somewhere else. When you destroy those are wiped multiple times. Now they're virtual, but when the hardware goes bad, before it's ever reused, it's completely zero. Hopefully that answers your question. That's about as far in as I can get into it. Then we do have documentation on our security that I can get you some links for, but hopefully that helps. Probably not to your satisfaction, but hopefully that gives you some idea. Again, privacy, security, top things that we do. So, what other questions? I think they just poked their head in and it's lunchtime, so. Anybody want to ask another question? You guys hungry? Let's get some food. I'll tell them we're ready.